Hi, my name is Ben White. I co-founded Rivelin Rail, and today I'm going to show you some key features of our PRT300 Tribometer and how to take a friction measurement. We've developed this portable piece of equipment to give you the most accurate friction measurements possible over a wide range of conditions. So we pick it up by these small handles. It's important to use these rather than holding the lid because that helps protect the belt drives that are underneath. You've got the steel measuring wheel, and that can be replaced if required with a small Allen key. We've got the magnets that clamp it to the top of the rail. We've got a spring-loaded temperature sensor in there for railhead temperature. We've also got additional temperature sensors in the sides for air temperature and relative humidity. We've also got a little lateral position guide here. This is a small thumb screw. You can move that back and forth, and that butts up against the face of the rail to ensure your measurement wheel is in the correct position on the railhead every time for repeatable measurements. So we place it on the rail, and this little lateral position guide butts up against the face of the rail. The left-hand magnet is turned on first, and that switches on in the anti-clockwise direction. Next, we tighten up the right-hand magnet, and at this point it's important to make sure that they're parallel to the direction of the rail. In this position, the magnets are lined up parallel to the rail and the tribometer is stable on the railhead. If they weren't lined up parallel and the tribometer is now skewed, we get a bit of a rock on the tribometer, and that will cause a different friction coefficient to be measured in each direction. You'll be able to see it in the results, but also feel it on top of the rail. All we do here is make sure that both magnets are aligned with each other for that stable position. As long as the tribometer is turned off, the motors are disengaged and the carriage is free to roll up and down manually, and that means we can make sure that the measurement wheel is in the desired point in the rail running band. The power button is on the back, so we'll turn that on. Now you're ready to run a test. Once we turn it on, the screen displays a list of configuration files. These can be specified by the user, but the default value is 100 newtons, 200 millimeters per second of speed, and 3% creepage for 4 repeats. By keeping it at this default value, it means you'll be able to compare results to our existing friction library. So we can press Next to cycle through configuration files, or we can press Select to pick that one. This will come up with a display of the contact conditions used for the test, and then we press Start. So that's finished the test with 4 repeats, and here we've got the repeat number, the actual measured normal force, the friction coefficient, which in this case is 0.3, the air temperature, the relative humidity, and also the railhead temperature. And by pressing Next, we can cycle through the average of each one of those measurements. Here we're on a disused piece of railway. There's a lot of iron oxide layer that's built up. For the very first measurement, the high contact pressure, representative of a real wheel rail situation, ends up breaking through that oxide layer. And this can cause a different friction coefficient for the first measurement compared to subsequent measurements. So in this situation, we can run the tribometer up and down for 4 or 10 cycles, for example, to create more of a steady state in friction conditions. The second configuration file on your tribometer is for 10 repeats, and it might be useful in this situation for first test of the day. If I was running a test, I'd be noting down the railhead conditions, whether it's dry, wet, or whether any friction modification or treatment has taken place. And then the most important bit of information to write down from the tribometer is the measurement number. This is displayed in the top left corner of the screen. So once you've taken your measurements and made a note of the file name, You can disengage the magnets and move the tribometer along to the next measurement site. And by doing this, we can build up a lot of information about how friction varies along this stretch of track. Once we're done with our testing, we can disengage the magnets. Remember to pick it up by its handles, and then we'll clean the wheel before putting it back in its box. So the tribometer results are displayed on a screen, but we can also remove the data using a micro SD card down here, which is located in the bottom of the screen. We press that to take it out, and it is the opposite way up to what you might expect. So the shiny side facing upwards. Once we remove that, we can put that into a PC. So here on the micro SD card, we've got the configuration files folder, where the user can make their own config files, changing contact conditions or number of repeats, for example. And next we've got the summary file. This is a CSV file. It contains information about the friction, the environmental conditions, and also GPS measurements, along with time and date. And each measurement, an average of this, will be put into a row in the summary file. We've also got the results folder. This gives you 300 data points for every measurement that you take if you really want to get stuck into the data analysis for every single measurement. So this is the summary file on the micro SD card. This is probably the most important one to look at when you're analysing the data. Here we've got the date and time of the measurement. You've got your tribometer name, which will be unique to each tribometer, the configuration file that's been used, the repeat, the speed of the wheel, the angle of attack of the wheel in milliradians, the normal force that was applied throughout that measurement, and the tangential force. And by dividing the tangential force by the normal force, this is how we get the friction coefficient. Here we've got the air temperature, the relative humidity, the rail temperature, the file name, which as we mentioned before is important to write down every time you do a measurement, the GPS, latitude and longitude. So here we're going to create a column for the friction coefficient, and as I mentioned before, all we're going to do is divide the tangential force by the normal force. So in that situation, the coefficient of friction is 0.28, and we can expand that to work it out for every test carried out. The charging port is found underneath the screen. We can supply one of these barrel plugs for every country. And then the percentage charge is then displayed on the screen. It takes around an hour and a half to fully charge. I hope that explains everything that you need to know to take a friction measurement with our PRT300 Tribometer, but we've got a lot of experience using these in the field in different environments, so please get in touch if you've got any further questions.